So today we're going to take a look at lesson 3A.8, solving equations by clearing the fractions. So this is going to be a little bit of a different take on our notes to solving fractions or solving equations with fractions. Instead of just doing our normal operations of trying to get rid of the numbers with the variables, we're going to take a look at trying to get rid of the fractions and dealing with whole numbers throughout the problem. You can find your notes on page 16 to 17, and today's date is there on the screen for you. So before we actually take a look at the notes, when you turn to this page, you should notice that at the top it has a warm-up for you. Now, this warm-up is just to get you ready with working with fractions, so I want you to solve it like you would have normally done by just trying to get rid of the numbers, trying to get the variable all by itself by doing the inverse operations, whether you're having to add or subtract, multiply or divide. I'm going to give you guys about 5 minutes to do this, so go ahead and get started on these. We're going to keep recording, and then once you guys get to a place where you're ready to look at these, I'm going to go ahead and start solving through. If you get these solved before the 5 minutes is up, you're more than welcome to go ahead and fast forward to get to that place, but I am going to record for 5 minutes. So go ahead and take this time to work on these problems and get yourself to a place where you're ready to look at the answers. So the 5 minutes that I have given you guys to go ahead and solve these is up. If you're not quite done and you need a little bit more time, you're more than welcome to pause this so that you can get these finished and then resume it so that you can check your answers and make sure that you've done these right. We're going to take a look at number 1 to start. So we have that x plus 5 over 6 equals 3 over 8. So the one step that I need to do to get x completely by itself is to get rid of 5 over 6, and to do that I have to subtract it. So I'm going to subtract 5 over 6 from both sides, and when I do this I get that x is equal to negative 11 over 24. Remember that when dealing with fractions in your calculator, use the ABC button. For fractions. If you have something that has a whole number, you'll just use this button twice and put the whole number in first. For number 2, we have another one-step equation here that in order for us to get x completely by itself, we have to get rid of 4 over 5. Right now, 4 over 5 is multiplying to my x. So in order to get rid of it, I'm going to divide both sides by 4/5. When I do that, it cancels off the original side that I wanted it to, and I get that x is equal to negative 10. And sometimes that's going to happen. Sometimes we'll still have a fraction as our answer. Other times we may have a whole number, and that's perfectly fine. On number 3, we're doing whatever we have to in order to get m completely by itself. But to do this, we're going to have a couple of steps to get there. I've got to get rid of this 1/10, and since it's subtracting right now, to move it over to the other side, I'm going to add 1 over 10. So this cancels and leaves me with 7 over 4n, and this is going to be equal to, and we have 2 ways that we could represent this answer. In the calculator, when you do this, it gives you a mixed number of negative 5 and 1/4. Or, if you are a person that likes to put these as improper fractions, this would become negative 21 over 4. So either of these answers is fine. They're both going to give you the same number in the end. Our last step to get m completely by itself is we're going to have to divide off the 7/4. So we're going to take and divide both sides by 7 over 4. And when we do this, we get that m is equal to negative 3. Last but not least, we need to do number 4. And so if we check number 4, it's very similar to number 3. We have a couple of steps that we're going to have to take in order to get our variable all by itself. So to start, we need to subtract 8 over 3 from both sides. This will get my c by itself, cancels there, and when we subtract, we get negative 2 and 1/4. And just like before, we could represent this as an improper number. So if that's you and you like to see the improper number, this would really be negative 9 over 4. And this is going to be equal to our 3 over 2c. Now, the last step, we need to get rid of 3 over 2. And so in order to do that, I'm just going to divide it off. Cancels here. And I end up with c equal to negative 3/2. Or, if you have the mixed number, negative 1 and 1/2. So these were our warm-ups to kind of get us started with fractions and taking a look at those. So let's continue in our notes and looking at how to clear the fractions. So rather than working with fractions, it can be easier to use a process called clearing the fractions. And so below we have some steps listed for us, just like we've had previously. First step is that we want to identify the least common denominator, or our LCD. This is used to clear our fractions, and that's what we do in step 2. We multiply the entire equation. Notice it's the entire thing, not one little part, not this little part, all of it. And this is what's going to clear the fractions for us. Even if it doesn't have a fraction, you're still going to multiply the entire equation by that LCD. Next, we'll use our steps that we've been using to solve previously in order to get the variable all by itself. So let's take a look at the examples that we have below, numbers 5 and 6. To start, we want to take a look at the fractions and see what our LCD is going to possibly be. If we take a look at the first equation that we have, number 5, 13 over 7x plus 4 over 7 is equal to negative 9 over 7. Well, notice our fractions here, our denominators, are all the same number. They're all 7. So in this case, the LCD is pretty easy to find. It's what they already are, 7. So now, what we're going to have to do in order to clear the fractions is we're going to take the entire equation. Notice I boxed the whole thing so that I know that I'm multiplying everything inside of there by a 7. And remember, the whole reason that we're doing this is so that we can cancel out the denominator. So if I were to just take a look at the first section off to the side, just so we understand exactly what it is that's happening. I'm taking the 7 that I have here and I'm multiplying it to 13 over 7x. The whole purpose of us doing this was, again, to cancel the bottom. 7 cancels with 7. And it just leaves me with everything else that's left over, 13x. And we continue that process throughout for all of these. So when I did it on here, 7 canceled with 7. 7's also going to cancel here with 7. And 7 here is going to cancel with our 7. So we're left with 13x plus 4 equals negative 9. And then now we're at a place where we can just start solving this equation like we normally would. I just want to do my inverse operations. So to get 13x completely by itself, we first need to move the 4 by subtracting it off. So I'm going to subtract off that 4. That cancels here, and I have 13x is equal to negative 13. Our last step to get x completely by itself would be to divide. So I take both sides and divide by 13, and I get that x is equal to negative 1. And that's it. Now, had it given me a fraction in the end, I would have kept it as a fraction. If you divide and you would have ended up with a decimal, make sure that you always just leave those as fractions. So let's take a look at number 6. And notice we have that situation here where some of them are fractions, but then we have this whole number of 2 here. And so anytime that I see that and it's not over a denominator, I can put it over a 1 if that makes it look a little nicer for us. But really, the 1 isn't going to matter here. The 2 numbers that I'm going to focus on that are going to help me with my LCD are the 2 and the 4, because 1 doesn't change anything in any kind of these problems. So between 2 and 4, I'm looking for the smallest number that they both divide into. Well, 4 can divide by itself, 4. And 4 is also divisible by 2. So in this case, our LCD is going to be 4. And in examples to come, I'll show you exactly how we can find this if we're not sure by just looking at the numbers and doing trial and error. But let's go ahead with our 4 here, and we're going to take that number times the entire equation. And below this, I'm going to show you what that kind of looks like for each part if we're taking it times the number of our LCD. So if I take 4 times the first part, 3 over 2a. Well, the denominator here, the 2, divides into my 4 and leaves a 2 behind. And 2 times 3 is going to give me 6a. Now notice, if you just put this directly into your calculator, 4 times 3/2, you should end up with the same result, the 6. The variable's still there and it's still attached, so I need to make sure that I don't forget that as I'm moving along. But now I'm going to continue, and I'm going to take 4 times -2, and I'm going to do 4 times -13/4 as well. And we're going to continue with this. Notice here, there isn't anything that's going to cancel out. 4 times -2 is just going to give us -8. And that's what we wanted. We wanted numbers that weren't going to be fractions. And so in this case, those whole numbers are actually a nice gift to us. It's a little less work that we have to do with fractions in a calculator. The last fractional stuff that we have when we multiply, our 4's end up canceling. 4 goes into 4 once and leaves me with 1 times -13, which is just -13. And this should be exactly what you would have gotten had you put this in your calculator the way that you see it on the screen. So now we're at a place where we just need to continue to solve. I want to get 6a by itself, so I need to move the 8 away by adding it to both sides. So I add my 8, it leaves me with just 6a, and this is equal to -5. Our last step, we need to divide both sides by 6. And when we do this, notice, -5 is not divisible by 6. So instead of trying to write this as a decimal, we leave it as the fraction that we see, -5/6. And we're done. Now these two examples were fairly easy. So let's kind of take a look at when trying to find that LCD is not as easy. I'm going to try this with number 7. And what I'm doing over here for finding my LCD, I'm going to kind of do off to the side of my screen. If you need to, you can kind of use the space that you have below here to find your LCD using the work that I'm about to show you. We've done this work previously in trying to find LCDs by just taking the numbers that we have and factoring them down, or breaking them down to be smaller and smaller primes. So we're going to take and start with 20. And can't write off to the side of my screen. So below, over here, I'm going to take the 20 and I'm going to start breaking it down. I know that the smallest number that 20 is divisible by, besides 1, is a 2. So 2 goes into my 20 10 times. Notice I've done a little bit of a different setup here. I'm using a reverse division bar. Instead of the little tree method that we had seen before, if I had taken and treed out the 20 this way and branched it out, it's a little bit of a different organization, but it kind of keeps the numbers a little bit easier to see what we have left and what isn't actually part of our answer anymore. So right now, 2 and 10 are part of my answer, and 20 is something that we're no longer using. But 10 can continue to break down. So I'm going to go ahead and continue to keep breaking it down. I put my little division bar around it, and now I know that 10 is also divisible by 2. And when I divide 10 by 2, we're left with 5. Now notice here, 5 is a prime number. The only way that I can break down 5 is 1 in itself. So we're done with this particular number. And now we're going to move on to the next one. So we're going to take a look at 10 and what that looks like when we start to break it down. And this is something we've already done previously. We know that 10 is divisible by 2, and when we divide, we get a 5. 2 and 5 are both prime, so now we know that we're done with trying to break down 10. The last number that we have is 4, and we're going to do the same thing. Break down this number by smaller prime numbers, and we know that 4 is divisible by 2. When we divide 4 by 2, we're left with 2. So, between all of the numbers now that we have on the outside, all of these broken down numbers, we're going to use those to help us come up with our LCD. To do this, we're going to figure out what numbers each of those had in common to start. Well, each of these, to start, were all divisible by 2. So this is a number that I know I'm going to have to use inside of my LCD. And I'm going to kind of show this above. So this is going to be part of it, but then I'm going to have some more numbers that they're going to have in common. So each number that they have in common, we're going to have to multiply. So I put my multiplication symbol down, and now I'm going to keep going. And now I'm going to start looking for numbers that they have in common. And it may not be numbers that every single one has in common, but as long as it's shared between 2 of them, we're going to be okay. So I still have this lonely 2 out here, and if I look, we don't have another 2 here, but we do have a 2 with the 4. So I know that this 2 and this 2, they have in common, and it's also going to be part of that LCD. So I'm going to write it down so I don't forget about it. Last but not least, there is one last number that they have in common, and that's the 5 that we have left. And again, this is just a number that's shared between 2 of them, which is okay. It's still shared, so I'm still going to include it. Now, if I look at the rest of the factors, we have used them all. Okay, we have no numbers that are on the outside of those division bars that we have not highlighted and used. If that were the case, we would need to include them in the LCD, but we don't have to here. So now I'm going to multiply these things together, and this is what's going to help me come up with our LCD. So 2 times 2 is 4, and 4 times 5 is going to be 20. So our LCD was 20. And notice that happened to be one of the fractions, the denominators that we started with in the fractions. And sometimes that'll happen, and sometimes that won't. So if you hadn't seen that 20 was going to be our LCD, now you have that way of being able to find it. So just like before, we're going to take and multiply all of these fractions by 20 so that we can try to clear our denominators. So we're going to take the first fraction, and just like I did before, I'm going to show you separately how I would multiply each of the fractions in order to cancel. So we're taking 20 times 101 over 20, and here the 20s end up canceling. That leaves a 1, and 1 times 101 is just 101. And this is going to be equal to, and we're going to do the next step of showing 20 times 13 over 10w. And again, 10 is going to cancel into 20, and it's going to leave a 2 behind. And so I continue. 2 times 13 would give me 26w. Last but not least, we're going to take 20 times 15 over 4. And our denominator will cancel. 4 goes into 20 5 times. And 5 times 15 is going to leave us with 75. Notice here, I don't have any fractions left behind. All I have are whole numbers. And had you just taken 20 times that whole fraction, 20 times that whole fraction, you should end up with the numbers that we see here on the screen, and not having to do the cancellation like I'm showing by hand. We're still trying to get W by itself, so my last step here, I'm going to subtract the 75 from both sides. 101 minus 75 gives me 26. This is equal to 26W. Last but not least, divide both sides by 26, and we get that W is equal to 1. Let's take a look at our next one, number 8. Again, see here, we don't have a denominator underneath this whole number, which is actually a benefit to us. Less numbers that I have to focus on for the LCD. So we're going to take a look at 2 and 9, and we're going to use these numbers in order to help us come up with the LCD. Well, 2 in this case is only divisible by itself in 1. So if I do that, it's divisible by 1, and I know that the answer is just 2. With our 9, we have a little bit of a different situation here. 9 can break down. It's divisible by 3. So if I take 3 on the outside, 3 goes into 9 3 times. And now we're done. 3 is a prime number. So if we look at the numbers that we have on the outside, notice we don't have anything that they have in common. So all of the numbers that we see here are going to be used in our LCD. Well, if I know that I'm going to have to use all of the numbers that I have on the outside anyway, those numbers make up the one that I had on the inside. So really, for this problem, we are just taking 2 times 9 to get the LCD. And this gives us 18. This doesn't always work out, but if you use this method throughout these problems, you should always end up with some denominator that's going to help you cancel, even if it isn't the lowest one. So we're going to take and use the 18, and we're going to multiply our whole equation by 18. So 18 times 7n, 18 times negative 1/2. Notice I'm keeping the sign with the fraction so I know what it should be below. And then we're going to take 18 times 20 over 9. So let's start canceling. 18 times 7. Here we don't have a fraction, so we don't actually have any canceling that's going to happen. So we're just multiplying across to get the number. So 18 times 7 is going to give us 126n. 18 times negative 1 over 2. 2 goes into 18 and leaves me with a 9. And so 9 times negative 1 is negative 9. This is going to be equal to, and then we have some cancellation that's also going to happen here. 9 goes into 18 twice, and 2 times 20 is 40. Now to solve, I need to get 126n by itself. So I'm going to add 9 to both sides. This gives me 126n is equal to 49. And then my last step here would be to divide both sides by 126. Notice, 49 is much smaller than 126. So when I divide, I end up with a fraction, or with a decimal here. You can convert that decimal back and it'll give you a fraction. Or if you already know that it's not going to work, or you test it and it doesn't work, you can just enter the number that you see here in as a fraction, and hopefully it reduces it the way that you want it to. So if we do that, I would have 49, and I push my ABC button, pops up that backwards L, put in my 126, and when you hit equals, this one reduces for you and leaves you with 7 over 18. And then we're done. So let's keep going. Number 9, we have 5, 2, and 5. So really we're only dealing with 2 numbers here for the denominator. We're using the 5 and the 2. And these are also prime numbers. That means that when I go to break them down, all they're going to break down to is 1 in themselves. So we're just going to take these 2 numbers for our LCD and we're going to multiply them. And so we get for our LCD a 10. That 10 is what's going to be used to multiply to everything inside of our equation. So when I do this, 10 times the first part, and then 10 times the middle, and then 10 times the last. And when we start to simplify, 10 times our negative 18 over 5 leaves us with negative 36. 10 times negative 1/2 k gives us minus 5k, and this is equal to negative 26. So now we're at a place where we can start solving our equations, trying to get the k by itself. So I need to move the 36 away by adding it to both sides. So I add it over, it cancels here, and leaves me with just negative 5k, and this is equal to 10. Last step is to divide by the negative 5, and we get that k is equal to negative 2. So on this one, I didn't exactly show you by hand what things would cancel and how they would look, but I wanted to give you guys some practice with trying to enter these numbers into your calculator and multiplying by them so that you can kind of see on your own how those numbers will cancel and what you'll be left with behind. Let's go ahead and take a look at number 10. We have 11 over 12 is equal to 3/2 x plus 5 over 3. So, looking between 12, 2, and 3, I want to take and break these numbers down so I can see what the LCD is going to be. I know that 12 is divisible by 2, and when I divide it, it leaves me with 6. 6 can break down a little further, and I know it's divisible by 2, and when I divide, it leaves me with a 3. And now that I've done that, I can see that all of these numbers broken down leave me with prime numbers. Looking back at the numbers that we still have here, 2 and 3, I can already see that those numbers are involved here. So I know that I'm going to have to include a 2, and I'm going to have to include a 3, because I already have those here and here. So we're going to say that 2 is going to be part of our LCD, and 3 is going to be part of our LCD. So we've gotten those numbers from the 12. We've gotten those numbers from the other fractions that we had. But notice we still have this lonely 2 that wasn't included with anything. It was all by itself, didn't have anything else to share with the 2 or the 3 that we already used. But I can't get rid of it. It's still part of 12. So I'm going to have to multiply it at the end and use it in this. And when we remultiply these numbers back together, we end right back up with 12. So 12 is the LCD, and that's what we're going to use to multiply everything by. I'm going to do something a little bit different with this one. I'm not going to show you the breakdown like I had been with each of the others by multiplying each part by the 12. I'm just going to take the fraction and I'm going to multiply it by the number I need to. 11 over 12 times 12 leaves me with just 11. This is equal to 3/2 x times 12. We cancel, and we're going to be left with 18x. Plus, I take my 5/3 and multiply it times 12, and it leaves me with 20. Now we're solving to get the x by itself, so I'm going to start subtracting away my 20. I don't want it to be with the 18x. 11 minus 20 gives me negative 9, and this is equal to 18x. And when I divide both sides by 18, I get that x is equal to negative 1/2. Again, I know that negative 9 is not divisible by 18, but if I stick this in my calculator as a fraction, it simplifies it for me and leaves me with negative 1/2. We still have a few more examples to go through, and I'm going to take a look at a couple of these, and then with the others that are left, I will give you the answers for them so that you can kind of check and just make sure that you have this idea down. So I'm going to take a look at number 11 and number 13, and I'll leave you with the answers for 12 and 14. So our LCD for 11, if we're looking between all of our denominators that we have, we've got 4, 2, and 2. And I know that all of these numbers are related to the 4. Everything can divide into the 4. So my LCD in this case is going to be 4. If we did the breakdown like we had been doing before, you'll get this same answer. So I know that I'm going to take all of this equation and multiply it by this 4. So 4 times my r leaves me with 4r plus 4 times 1/4 leaves me with 1. This is equal to negative 3/2 times 4 gives me negative 6 plus 1/2 r times 4 leaves me with 2r. And again, I'm just taking those fractions, entering them into my calculator as fractions times that LCD. Now I'm at a place where I need to start solving my equation. I want to get my r's together on one side, and so to do that I'm going to pick on the little guy and move him to the other side by subtracting. So I subtract 2r here, and it cancels and leaves me with just negative 6 on that side. 4r minus 2r gives me 2r plus 1. I need to keep solving to get the r by itself. So I'm going to subtract 1 from both sides. This gets rid of the 1 here and leaves me with just 2r. Negative 6 minus another 1 gives me negative 7. And then when I divide by 2, I know that negative 7 is not divisible by 2. So I leave it as a fraction, and I get negative 7 over 2. Or if you're wanting the improper, negative 3, or not improper, I'm sorry, the mixed number, we would get negative 3 and 1/2. Let's take a look at number 13, and then I'll give you the answers for the other two. If you feel comfortable with this, and I know I have not said this up to this point, if you feel comfortable and confident with this idea of clearing your fractions, you're more than welcome to skip ahead and look at the homework assignment. But if not, I'm going to continue with a few more, and then you'll be ready for your homework assignment. So between 24, 4, and 3, I want to see what my LCD is going to be. Now, previously I've been saying this, and I've not really shown it. We said it on number 11, where 4 was divisible by the 2's that we had for the denominators. The easiest way to see is we can check our largest number down here, see if it's divisible by the denominators that we have. So 24 divided by 4 leaves me with 6. So I know that it works here. And 24 divided by 3 leaves me with 8. So it also works here. Because of this, I now know that the big number that I have here, 24, is my LCD. It's the smallest number that all three of those denominators have in common. So we're going to take and use 24 to multiply to all of our equation. I'm going to start doing that. So negative 13 over 24 times 24 leaves me with negative 13 plus 3/4 W times 24 is going to leave me with 18W, and this is equal to, notice we had one term in our equation that didn't have a fraction, but it's still going to get multiplied. So W times 24 is 24W, and then negative 2/3 times 24 is going to leave me with negative 16. Now that I have all of my whole numbers, I'm ready to start solving this equation. So I'm going to start combining my like terms. I'm going to move my 18 to the other side so that I can combine it with its like term. It cancels here and leaves me with just negative 13, and this is equal to 6w minus 16. Now I'm still trying to get 6w by itself, so I need to move the 16 over by adding it. And when I add 16 over, it cancels and leaves me with just the 6w that I wanted, and negative 13 plus 16 leaves me with 3. Last but not least, I need to divide both sides by 6 so that w is completely by itself. So that cancels away and leaves me with w equal to 1/2. Again, if you put 3 over 6 in your calculator as a fraction, it will reduce it for you and leaves you with 1/2. So, just so that we can take a look at 12 and 14, so you can kind of see whether you were on the right track or not. Our LCD for for number 12 should have been 60. And when you go through and solve, you should get that A is equal to negative 3 over 5. On number 14, the LCD that you should have come up with was 20. And when you take and multiply your whole equation by 20, you should end up in the end with P equaling negative 4. So again, sometimes we're going to have fractions left over as our answers, and sometimes we're going to have whole numbers. Either way, it's okay. But now we have an idea of how we can solve these equations by first getting rid of the fractions. That way we can just deal with whole numbers throughout until the very end. So let's take a look at today's assignment. You're going to be working on homework 8, solving equations by clearing the fractions. And you can find this homework assignment on page 40 to 41. Thanks for watching this video, and if you have any questions or you need any help, please take this time to ask. I'll be more than happy to come over and help you with any situation that you're having problems with. And I want you to take this time to work on your homework assignment or grade any homework that you still need to turn in to get your early in bonus.